Welcome you all in the video lecture series of Engineering Mathematics. In this video lecture, we are going to discuss about some properties of Laplace transform. So earlier you have studied about the Laplace transform. So in this section, we are going to discuss about the properties of Laplace transform. First we see which property we are going to discuss here. So initially, first property we will discuss about the linear property of the Laplace transform. Then we go for the first shifting theorem or property of the Laplace transform. Then we go for the change of scale property. Then fourth one is Laplace transform of derivative, which is very important to solve the differential equation or system of differential equation. And the last, Laplace transform of integral. It is also very useful in solving the differential equations or interdifferential equations. So let's see one by one the properties of Laplace transform. Let's see the first property we have, linear property. So you have studied many more times linearity of the function. Same way, suppose Laplace transform of ft is given as fs and Laplace of gt is given as gs. Then Laplace transform of c1ft plus c2gt is equals to c1fs plus c2gs. So how we can prove this? Since we have Laplace of ft, that is integration from 0 to infinity e to the power minus st ft dt, and the Laplace of gt is integration from 0 to infinity e to the power minus st gt dt. So in that case, first we go for Laplace transform of c1 ft. So in the place of ft, here we write c1 ft. Same way, since c1 is constant, so c1 comes outside of the integral. So it is c1 0 to infinity e to the power minus st ft dt. And finally we write Laplace of c2 gt is 0 to infinity e to the power minus st c2 gt. Again c2 comes outside of the integral, so this we get. Now we go for the left hand side. Laplace transform of c1 ft plus c2 gt, that is integration from 0 to infinity e to the power minus st, and in the place of ft we write here c1 ft plus c2 gt dt. So as for integration we can operate for these two functions separately. So it is 0 to infinity c e to the power minus st c1 ft dt and plus 0 to infinity e to the power minus st c2 gt dt. Now, as we have done earlier, c1 and c2 can go outside the integral, and this we can write as a c1fs plus c2gs, and this is our right hand side. Thus we prove the linear property of the Laplace transform. Now come to the next, the first shifting theorem of property. Suppose we have given Laplace of ft is fs, then we have to show that Laplace of e to the power at ft is f of s minus a. For proof, we have given Laplace of ft is what? By definition, it is integration 0 to infinity e to the power minus st ft dt. Now Laplace of e to the power at ft, we can write integration from 0 to infinity e to the power minus st e to the power at ft dt. So by adding the power, it is e to the power minus of s minus at. Now here we take u is equals to s minus a, which is greater than 0. So it becomes 0 to infinity e to the power minus ut ft dt. So when we compare with the definition, simple s in the place of s we have taken u, so it is going to be fu. and u is what? It is s minus a, so it is f of s minus a. Thus we have proved the first shifting property. Similarly, if it is given Laplace of e to the power minus atft, then it will be f of s plus a. So this property is also useful when we solve some questions related to Laplace transform. Now come to the next, it is change of scale property. Suppose Laplace of ft is given fs, then Laplace of f of at can be given as 1 upon a f of s upon a. So Laplace of ft, as we know, it is fs, then Laplace of f at we can write integration from 0 to infinity e to the power minus st f of at dt. Now here we suppose that at is equals to x. In that case, a dt is what? Dx. And what about the limit? T tends to 0, so that x will also tends to 0. As t tends to infinity, x will also tends to infinity. So by putting these values, we get here 0 to infinity e to the power minus sx upon a. In the place of t, we have written x upon a. Fx dx upon a. As dt is what? Dx upon a. So 1 upon a is going to outside, so it is 0 to infinity e to the power minus sx upon a fx dx. Now here we put x is equals to t simply to convert the for notational point of view only. So it is 1 upon a 0 to infinity e to the power minus st upon a ft dt. Now this will equals to, here we have taken s upon a is equals to p. So it is 1 upon a 0 to infinity e to the power minus pt ft dt. Now you can compare with the formula of Laplace transform. In the place of e to the power minus st ft dt, we have kept here, it is p e to the power minus pt. So this is 1 upon a f of p, and as you know, p is what? It is s upon a, so it is 1 upon a f s upon a. Thus we get the result in the form of change of scale property. Now we see the most important property of the Laplace transform, that is Laplace transform of derivative. This property is useful in solving differential equations or system of differential equations. So suppose Laplace of ft is given fs, then Laplace of fnt is given as Sn fs minus Sn minus 1 f0 minus s to the power n minus 2 f dash 0, and so on. And lastly we can write minus of s f of n minus 1 0 and minus fn 0, where fnt is what? It is nth derivative of ft, so it is dnf upon dtn. This property we have to prove here. So suppose Laplace of ft is fs given, then Laplace of f dash t, so we start with the first order derivative, then we go up to the nth order derivative. So Laplace of f dash t is what? It is 0 to infinity e to the power minus st and f dash t dt. In the place of f dash t, we have written df upon dt. So we can apply here integration by part. So e to the power minus st we have taken the first function, and f dash t we have taken the second function. So it is e to the power minus st ft, and the limit we put t is equals to 0 to infinity, then minus 0 to infinity, and derivative of e to the power minus st is minus s e to the power minus st and ft dt. So by putting the limit here, if we put here the infinity, then it is going to be 0, and when we put 0, it is minus f of 0, and in second case it is going to be s fs. So minus s goes outside and it becomes the Laplace of ft. Thus we have Laplace of first order derivative f dash t is what? S fs minus f0. So you can compare with the result. Initially, by putting n is equals to 1, we get s of fs minus f0, and this term is neglected here. Now suppose we have gt is equals to f dash t. In that case, Laplace of f dash t, it is Laplace of gt, and that we define in the form of capital G s. Again we apply the same property here. Laplace of g dash t by 1, what we can write? sgs minus g0. As you know, capital Gs is what? Laplace of gt. So it is again, and gt is what? F dash t. So in the place of gt we have kept here f dash t, and Laplace of f dash t is what? Sfs minus f0, and finally minus 0. So simplified, Laplace of f double dash t is going to be s square fs minus sf0 and minus f dash 0, as gt is f dash t. Again you can compare with the statement, it matches with the statement here. Similarly, if we go for the third order derivative, it is going to be sqfs minus s square f0 minus s f dash 0 and minus f double dash 0. So we can repeat this process up till n, and we can continue this process. We get the required result. This is our result that we get by continuing the process. Now come to the next, the Laplace transform of integral. So if Laplace of ft is fs, then we have to show that 1 upon s fs is what? Laplace of integration of 0 to t fu du. So we start with the concept Laplace of ft is fs and gt that defines 0 to t fu du. In that case, g0 will be 0, we have to put the t value t is equals to 0, so it is integration 0 to 0 fu du, and g dash t will be derivative of integral 0 to t fu du. So this is going to be ft. Now using Laplace transform of derivative, what we get here, it is Laplace of g dash t is what? S Laplace of gt minus g0, and as you know, g0 is what? It is 0, and Laplace of gt we have, so it is s Laplace of gt. So capital Fs is what? S L of gt, and gt is what? As we have seen, gt is what? Integration from 0 to t fu du, and s we have taken the left hand side. So finally we get the result 1 upon s fs is what? Laplace of integral from 0 to t fu du.